This video brought to you by Lego Snow Speeder Stormtrooper or something. Okay, so this identity um, illustrates the need for you to really have good algebra skills and be able to apply those to all things. I really think a lot of these chapter 6, these trig problems are all about, hey, do you really know your algebra? Can you now apply them to kind of wonky looking other things? So, for example, we're going to use our strategy of pick the most ridiculous looking side and simplify it as best as possible. I'm going to argue this is the most ridiculous looking side, and I'm going to ask you to recall what a cubed minus b cubed factors to. You can, you might have a formula memorized, and it might look like this. And if you don't remember that, look at your reference sheet notes. It's in there. It's the difference of cubes. So I'm going to factor out this numerator, and you're going to see that this piece, hopefully you're seeing, is the same thing as this one. In other words, my a cubed, my a is cosine, and my b is sine. So this numerator factors to cosine minus sine, all of that times cosine squared plus sine cosine plus sine squared. I guess I should put brackets on there so we don't get confused on that. And then, of course, that's all equal to this 2 plus sine 2x all over 2. And again, I'm going to leave this sitting here for a while, and at the end, we'll see if they need to be the same. Okay, so recall that all of this is still being divided by cosine sine, but now minus sine, excuse me. But now you should note, oh, these are common factors. So because we have a product in the numerator, and this, you could think about this as times 1 or something of that nature. Note that these factors divide to 1, and we're left with this sine squared x, or this mess in the numerator. Now, when I rewrite this, I'm going to put the sine squared next to the cosine squared just to help you see what I'm seeing. The reason I can do that is because the order we add things does not matter. So what I am left with is cosine squared plus sine squared plus all of this is equal to that. Now notice, what is this equal to? Yeah, you got it. That's 1. This is that special identity. Cosine squared plus sine squared equals 1. So I can rewrite that as 1 plus sine x times cosine x. Okay, now we're kind of at an impasse. I'm going to rewrite this thing. And I'm going to factor out this 2. And note that this is, oh boy, let's see. No, I can't factor out a 2. I'm just going to rewrite this as 2 plus sine of 2x all over 2. Now, this looks like one of our half-angle identities. And that was that sine of 2x equals 1 plus 2 sine x cosine x. So let's take this right side now that we more or less have it. And let's rewrite what this sine of 2x equals to, because it might be easier to rearrange this into that. So sine of 2x is equal to, 2 sine x cosine x. So this entire piece became this. Now what I want to do before I can actually do, there's a 2 in common between each of these. So I'm going to factor that out and write this as 1 plus sine x times cosine x, all divided by 2. Now they're a common factor, so we can cancel them. You could also think about splitting this into 2 separate fractions. Either way, it doesn't particularly matter. And now we have 1 plus sine x cosine x. Isn't that really satisfying? That is the same as this thing over here. So I'll just rewrite this down here, 1 plus sine x cosine x, and we've done it. We've shown that the left side is equal to the right side.